Okay, so this video is going to cover section 11.6 in the geometry book. It's over volume of a sphere. We're going to start off by talking about where this volume formula comes from, but then we're going to apply that volume formula to basically finding the volume of spheres and hemispheres and a few other little examples of where those might show up in real life. To start off with here, I'm going to go ahead and just show you this video. It's a lot easier than trying to videotape myself doing this, and he's got some nice animations. I hopefully here, I'm going to hope this mutes it without muting me, and then I'm going to talk over it. So we're going to start here just by using some water with a cone. So you can see he's got a cone full of water, and we're going to see how many cones it takes to fill up that sphere. Now he's dumping it in that prism just so that it's easier to pour out of that corner of the prism. But you can see there, one of those cones filled up about half of it, and two of those cones fills it right to the top. And so we basically assume here, or kind of conclude, that two of those cones have the exact same volume as one of the spheres that we're going to talk about. So we're going to start off with just the volume formula of a cone. We'll talk about that. For a cylinder, we talked about how that's just the area of the base, which is pi r squared times the height, which we usually just call h. And so, we usually didn't write this whole thing together like this. We focused on find the area of the base, multiply by the height. But that would be one way to write that formula all together, pi r squared times h. If we switch this to a cone, it's got the same formula just with a divided by 3 on it. So we talked about that. Now, what you just saw here was that two of those cones are equal to the volume of a sphere, and that is assuming that the heights of those cones matches what we really would call the diameter of the sphere, and then that the radius of the base of those cones matches the radius of the sphere. And all of these geometry sets are set up so that they have the same radius and the same height and all that stuff already built into them. So we took the the volume formula for a cone, pi r squared h divided by 3, and then again adding it on, so we've got two of them, pi r squared h divided by 3, and we know that equals the volume of a sphere. Those two cones together add up to the sphere. The first thing we got to do is we're going to deal with that h. In a sphere, we don't talk about height. We only talk about things like radius and diameter. Well, the height is equal to the diameter of the sphere. It goes all the way across. And so instead of saying pi r squared times the diameter, we're going to replace it with 2r, basically. They're going to show r plus r first. But really, r plus r is 2r. The height of the sphere is twice its radius, which is the same as the height of these cones. So r plus r is 2r. And then the only thing we got to do now is just rearrange and simplify. We're going to stick the 2 in the front because we like numbers in front, and it's all multiplication, so it doesn't matter. Then we're going to deal with that r squared times r, which makes r to the third power. And so we've rewritten these two pieces as 2 pi r cubed over 3, and we're adding them together. And so now all we got to do is just add them together here. They're going to do this in a little bit of a strange way. They're going to write the fractions out front, 2/3 pi r cubed plus 2/3 pi r cubed. But when you add those together, 2/3 plus 2/3 makes 4/3 eventually. And then, of course, his little cards get in the way. So we've got adding those together makes 4/3 pi r cubed eventually, maybe. And so that's one way to write the volume. And then, unfortunately, he hid the other equation back there, but I'll show you what that is too. So we've got our one volume formula we can use, which is 4/3 pi r cubed. The other way we could write that, which is sometimes nicer, is 4 pi r cubed over 3. That's exactly the same thing, because what you're thinking about here is these both are over 1, and then we just multiply the tops, multiply the bottoms, and that's one big happy fraction. So sometimes it's easier to think about it in terms of this one, and sometimes it's easier in terms of this one. So most of the time, I think most people prefer this one. But one thing you'll see, there's a couple examples in the homework where r is a fraction, in which case this version is kind of nice, because then you don't end up with a fraction divided by 3. Although with a calculator, it's not that big a deal. Okay, so let's just do a couple examples here. I'm going to find the volume of this sphere. One thing I would really expect to see here is that we're at the very least writing out our formulas. If not this step, where you write it with it blank, at least writing it with the numbers plugged in. So 4 pi times 4 cubed over 3. Here, it's just a matter of, let's do our order of operations. We always want to take our exponents first. So we simplify that. Volume equals 4 times pi times 64 over 3. The next thing we want to do is we'll do our multiplication. Now, we want to leave this in terms of pi, so I'm just going to kind of leave the pi here, and I'm going to multiply the numbers, because it doesn't matter what order I multiply the numbers in. And so 4 times 64 is 256. If you need a calculator for that, I am not surprised at all. That is, only know that because I just did it in both classes. So I move the pi to the end, I multiply the numbers, and then I end up with this still divided by 3. At this point, you'd want to check that fraction in front. Make sure you can't simplify that. In this case, I can't simplify that. And one way to know is that all of these numbers, 4 and 4 and 4 and 4, none of those divide by 3. So I'm not going to get anything that simplifies. But I might have some where that does simplify, and I would need to be aware of that and check for that. You can absolutely check for that right on a calculator. Just type that in and see if it simplifies. Okay, so let's go ahead and just kind of show you how you might want to use a calculator to help you out with this. I'm going to pull a scientific calculator over here. And one of the best places to go when you want to actually use a calculator is go right back to the beginning here. All I'm going to do is just rearrange this so the pi is at the end. 4 times 4 cubed pi over 3. And I'm just going to type this part into the calculator. I cannot forget that pi. It is still that pi. I'm just simplifying the numbers part. So on a calculator then, I could go 4. Of course, that's in the way. 4 times 4. Oops. Sorry, so here we go. 4 times 4 to the third, and then all of that's being divided by 3, and it tells me 85.33, but a fraction 256 thirds, and so I could write that as 256 thirds pi, or I could write it exactly the same way I did here, with the pi in the numerator along with the 256. That's fine too. Okay, let's go ahead and talk about a hemisphere now. A hemisphere is just half of a sphere, and so as long as we are talking about volume, it's as simple as taking half of the volume. And we could find the volume of the whole sphere and then just divide it by 2. We could also look at this and say, okay, well, if the volume of the whole sphere is 4 pi r cubed over 3, the volume of a half of a sphere is going to be 2 pi r cubed over 3. That's just half of what it was. So I'm going to take my hemisphere here, 2 pi r cubed over 3. And just as a reminder here, so you can see that, that's because that is half of 4. Right? And I'm going to start just plugging in my numbers here. 2 times pi times 2 cubed over 3. I'll do my order of operations here. 2 cubed is 8. And then I know that 2 times 8 is 16. So 16 pi over 3, and nothing with 16 and 3 simplifies at all, so we're good to go there. This would be meters cubed because we're talking about volume. I didn't put that on the last one. And that's, again, the same thing. I could go to a calculator at this point and kind of think about it being rearranged and type that part into a calculator. Just don't forget there's still a pi there. Okay, last one, we're going to go ahead and work backwards here. They give us the volume, and they're asking us to find the radius. So I'm going to start off again, writing out the formula. Volume equals, this is a hemisphere, so 2 pi r cubed over 3. What I know is the volume is 144 pi equals 2 pi r cubed over 3. When I go to solve this equation, I'm working backwards here. I'm seeing this divided by 3, so I'm going to multiply by 3 on both sides. That's going to cancel out. That times 3 and that divided by 3 are going to cancel each other out. I get 432 pi equals 2 pi r cubed. And again, the whole idea here is I'm working back towards this r. So the next thing I want to divide by is 2. While I'm at it, I can divide by pi. And that's going to, pi's are going to cancel, 2's are going to cancel, pi's are going to cancel. And 432 divided by 2 is 216. Now at this point, since we're trying to find r, we are trying to find a number where it's r times r times r equals 216. A number times itself makes 216. If you don't happen to know what makes 216 that way, this is where we got the idea of inverse operations. When we were talking about square roots, if I had r squared equals 81, I could take a square root. We have r cubed. We are taking a cube root, and we denote that with this little 3 up above the root symbol. So a cube root and a square root, a cube root and a cubing is undoing each other. And then to find the cube root of 216, you just need to grab a calculator. And the cube root button, the button you're going to use for cube roots, is this one right here. It's this n root. Now let's just do any root, a cube root, a 4th root, a 10th root, a 100th root, whatever. Click on that button. It's going to ask you to type in which root you want. So we want the 3rd root. And then we'll go down here and we'll do the 3rd root of 216. And it tells us, well, that is 6. So our radius is 6. And the reason that works is because 6 times 6 times 6 is 216. And if you really wanted to, you could, of course, go back and plug 6 into our formula here and check that it worked. I'm actually going to do that because that's going to show a good example of simplifying here. So the volume of our hemisphere is 2 times pi times 6 cubed over 3. If I go ahead and start working through that, I've got 2 times pi times 216 over 3. I could multiply by 2. That's going to equal 432 pi over 3. And to check to see how that simplifies, I could grab a calculator and type 432 divided by 3, and it says that's 144. So we get 144 pi as our volume, which is exactly what we started with. Even if you had gone way back up here and turned it into 2 times 6 cubed times pi, you move the pi to the end, you could type that into a calculator. 2 times 6 to the 3rd power, all divided by 3, and you get 144. So that stuff in this that's circled is 144. Don't forget your pi if you're typing it in a calculator. I, at the very least, would expect to see this part, and then if you're simplifying, showing me your steps. If you're not, make sure you're typing the stuff in the calculator and not losing that pi. That is a big important thing, that pi be there. Okay, so your homework here is going to be on page 263. It's 1 through 5, 8, and 10 through 12. So we've got those examples there. You could pause the video here if you just wanted to work on them from that. And then down here, 8 is an example of just a word problem that they use. Number 10 is asking you to find the volume of 2 different things and compare them. And then 11 and 12 are working backwards. So they give you the volume and they want the radius. They give you the volume and they want the radius. The one that I did want to go through was just something like number 2 with a fraction in it. That is a good example of where we might want to use that original 4/3 times pi r cubed. And I'll show you why here. So if I'm going to do this one, volume equals 4/3 times pi times a half cubed. Well, when we take a half cubed, we're taking a half times a half times a half. Multiplying across the top gives us 1. 2 times 2 times 2 is 8. So I get 4/3 times pi times 1/8. And I can rearrange these so it's written as 4/3 times 1/8 times pi. And at this point, I can simplify this. 4 and 8 both have a factor of 4 in them. So I can factor out 4 there and get 1. I can factor out 4 there and get 2. And now I can just multiply straight across. 1 times 1 is 1. 3 times 2 is 6. So I could write that as 1/6 pi. Or I could think about that as pi over 1 and multiply these together. 1 times pi is pi, 6 times 1 is 6, and that is usually what you're going to see an answer as in the book, is pi over 6 as your final answer in centimeters squared, or centimeters cubed, I guess. I would certainly take 1/6 pi as well. So number 3, very, very similar to that. You're doing a hemisphere, so it would just be 2/3 pi times the radius, 3/4 squared. You can work through that one on your own then. Last thing I'll mention on this is number 5. Number 5, they give you this slant height. They give you this radius. But what they don't give you is the actual height that you need to find the volume of the cone. So start by finding that height using the Pythagorean theorem, as that is a right triangle. Then you can find the volume of that cone.